Welcome to today's lesson. We are going to talk about common factoring. Let's recall the distributive property. When we're expanding an algebraic expression, we have a number like the 2 bracket x plus 3. We know that this means we're multiplying. So we're going to take the 2 and distribute it to everything inside the bracket. 2 times 2, then 2 times 3. So this is equal to 2x plus 6. Now what we've just done, we went this way, and we call this expanding. When we go backwards, going from the expanded form back to the factored form, we call this factoring. And this is the main point of today's lesson. Now, before we get to the factoring, I want to make sure that we are all good with the expanding. Great, so example number 2, we have negative 3 times x squared minus 2x plus 1. We're going to take the negative 3 and expand it uh, by taking it and multiplying every term inside the bracket. So I have negative 3x squared plus 6x minus 3. The two negatives become a positive. Then my negative and positive becomes a negative. Third example, 2m times 3m plus 4. Right now, we have to remember that exponents are involved as well. I've got an m here and an m here. So now we have two m's multiplying each other. The expanded form, we have now 6m to the power of 2 plus 8m. So just a quick reminder, remember the exponent rules. We applied the product rule because we have two powers with the bases that are the same. Multiplied together, I have m squared. Let's talk about expanding binomials now. So remember FOIL? That was the acronym that we used to represent first, outside, inside, last. Meaning when I have two binomials and they need to be multiplied, I'm going to take my first term, multiply everything in the second bracket, and then I take the inside term and multiply everything in the second bracket again. So expanded, we have x squared plus 6x plus 3x plus 18. We're going to collect the like terms, so the middle two there, and we have x squared plus 9x plus 18. Great. The next example we have 2x plus 1 times 2x minus 3. Same idea as our other question. We're taking our first term, multiplying the second, 4x squared. Then the outside term multiplying the second one, 6x. Inside term is going to multiply everything in the second bracket now. Collect the like terms, and we have 4x squared minus 4x minus 3. Okay, when we have a question like this, 4 bracket x plus 1 bracket x plus 2. We need to remember that the order of operations says we need to do our brackets first. In this case, the brackets are multiplying binomials. So let's expand the binomials with the 2 brackets, and then we'll distribute the 4. 4 times x squared plus 2x plus 1x plus 2 equals 4 bracket x squared plus 3x plus 2, and then 4x squared plus 12x plus 8. We collected our like terms inside the bracket, and then we took the 4 and distributed into the bracket. Part D, k plus 9 all squared. So remember, if I have something that's all squared, the exponent means we have to take the base and we're multiplying it by itself. So since it's exponent 2, I know that I'm going to have 2 bases multiplying itself. K plus 9 times k plus 9. When I expand it, we have k squared plus 9k plus 9k plus 81. Collect our like terms, k squared plus 18k plus 81. Okay, last example. Let's expand it. We have n squared plus 3n minus 3n minus 9. Collect the like terms, n squared, 3n minus 3n. These two become a 0, so we don't need to write it. And we have negative 9. Okay, slides number 4 and 5. Please try these on your own. Pause the screen, and I'll take this up in a bit. All right, solutions for slide number 4. Solutions for slide number 5. Okay, now let's start our lesson now. We're talking about common factoring. And like I said, factoring is the opposite of expanding. Expanding distributes a factor across numbers, and the factoring will break a product into its component parts or factors. So how do you factor out a common factor? First, we're going to find the greatest common factor in the terms. Next, write the common factor outside the bracket, and inside the bracket, divide each term by the greatest common factor. And then we simplify. Now let's take a look at this. When I say the greatest common factor, I'm looking at all the things that composes 9. So 9, we could possibly have 1 times 9. We could also have 3 times 3. For 6, I have 1 times 6 or 2 times 3. Now, out of this list, 3 is common to both of them, and in fact, 3 is the largest common one. So I'm going to take the 3, put it on the outside, and then put a bracket. Inside, I'm going to rewrite the equation or expression, but I'm dividing everything by the common factor. So now when I simplify, I have 3 times 3x minus 2. This is my factored form, and this is the expanded form. Okay, let's try it for a question where we're looking at variables instead of numbers. Now, for variables, instead of looking at the greatest number, we're looking at the number of common variables we have. So an x squared means I have x times x, I have 2 x's, and in this, I have 1x. So out of those two, what's common is the x, 1x. I'm going to put this on the outside. And then on the inside, we're going to divide each of the terms by the common factor. So it turns out to be x times x minus 1. Once again, we had to employ the quotient rule for dealing with these powers. Example C, negative 4y squared plus 16y. Now this time we have a term and a number that's common. Let's just write out all the possibilities. Negative 1 times 4, 2 times 2, and we have y times y. For the 16, we have 1 and 16, 2 and 8, 4 and 4, and 1y. So out of this list, we have 1y that's common. We also have a 4. So my common factor here is 4y. Right, 4y on the outside. And we're going to divide each term now by 4y. Let's simplify 4y times negative y plus 4. Two more examples. These are a little bit more complicated now because we've got a lot more variables. So looking at just the coefficients here, common factor, we know that the 5 is the number that's common to all 3 terms. But now let's look at the variables. Okay, so for the first one, the variables, we have 3 x's, so x times x times x times y. The second one is made up of x times y times y. And our third one We have x times x times x times x times y times y times y. Now, looking at this, I see that two x's are common to each of these, and we have one y that's common to all of them as well. So our common factor, we have 5, two x's, which is represented by x squared, and one y. So this is our common factor. Let's put that on the outside of the bracket, 5x squared y, and we're going to rewrite the inside and divide each term by 5x squared y. Hey, simplifying using our exponent rules, the coefficients we just divide. So we have 3x. Next, we have 4y plus 7x squared y squared. Next example, 26a to the power of 4b minus 8a cubed b cubed plus 12b to the power of 4. There's no a in this one, and there's only one b in our first one, so our common factor in this case is 2b. Let's take a 2b out of each term. Now, if you don't need to show this step, you don't have to. You could do it in your head, but then you will need to write your final answer, 13a to the 3 minus 4a cubed times b plus 6b to the power of 3. Oops, okay, this is a to the 4. Slides 8, 9, 10, 11. Try these on your own. Pause the video and I will show the solutions shortly. Hey, this is the solutions for slide number 8. Solutions for slide 9, slide 10, slide 11. Sometimes we have common terms that are factored, not just a variable or a number. So when we're factoring common terms, we can say this entire segment or the whole bracket is common. So we're going to do the same thing and take the common term, put it on the outside, rewrite the equation now, but we're going to divide each of the terms by our common term. Now you'll notice that I used square brackets here just so that I can distinguish the difference between these two. Now the two brackets, because they are the same, I can divide those out, divide that out. I have y minus 1, and what I have remaining in my second bracket is 5x minus 3. Let's do the same thing here. We have a common term of x plus 3, but you'll also notice that inside our coefficients, we have a common number. Our common number is 2. So now our common factor altogether is 2 times x plus 3. So let's factor it. 2 times x plus 3. Rewrite the equation. And now we can divide out our common factor and common term. Right, 2x plus 3 times 4x minus 1. Sometimes we need to use common variables in order to help us solve. Now we know that when we're asked to solve for h, what it's saying is I need to find what h is equal to. So h equals blah, blah, blah. But the trouble is we have two terms with the letter h in it. The way we're going to get around this is we're going to factor out the h so that h is only one term now. 2a is equal to h times c minus b. Since h is being multiplied to the term c minus b, if I divided c minus b to both sides, then I have h isolated. We have 2a divided by c minus b, and this is equal to h. We've solved for the letter h. R minus 3a is equal to 5ac. Solve for a. We need to rearrange this first so that we can have a on its own. So R is equal to 3a plus 5ac. Factor out the a, 3 plus 5c, and we're going to divide now by this whole bracket. So R over 3 plus 5c is equal to a. Let's do this last example here. Common factoring with powers. This is a bit of a challenge question, but it's fun because this is something that is going to combine our knowledge of exponent rules and factoring together. So here's the hint. Let's take the power with the smallest exponent as the common factor. Now, since these are negative numbers, the smallest number would be a negative 6. We're going to factor out negative 2 to the power of negative 6 in both the top and the bottom. Okay, we've rewritten this. Now, for us to simplify, the numerator, we have 2 to the power of negative 6 times negative 4 minus 6. The two negatives become a positive, so we have 2 to the power of 2 plus 1. Denominator, 2 to the power of negative 6 times 2 to the power of positive 3. So the reason I chose the smallest exponent is because since I have all these negative exponents, I'm going to make it positive, and it makes my life a lot easier now. These two divide out, and we're left with 2 to the power of 2 plus 1, and in the denominator, 2 to the power of 3. So if I expand it, I have 4 plus 1, that's 5, and a denominator of 8. Let's factor out the power with the smallest exponent. This is 4 to the negative 12. So 4 to the power of negative 12 times 4 to the negative power of negative 12. Right, let's continue. These two divide out, so we're just left with our numerator and denominator. 1 minus 4 to the power of 1, and the denominator, 4 to the power of 2 plus 1. Let's keep simplifying. So I have 1 minus 4 and 16 plus 1, negative 3 over 17. Slides 15, 16, and 17. Please try these on your own. These are the solutions to the questions to try on your own. Slide 15, slide 16, slide 17. Okay, and that's the end of today's lesson.